Welcome to another River Publishers book discussion. My name is Philippa Jefferies, and today I have with me Kwang-Cheng Chen, Professor at the Department of Electrical Engineering at the University of South Florida and IEEE Fellow. I'm very pleased to have him with me here today to talk about wireless communications for AI and his book Artificial Intelligence in Wireless Robotics.
My background is, of course, in the wireless communication for my entire lifetime, and I've been got a different opportunity to touch different things, and from the as large as the satellite communications, and from the radio and also opticals. And actually, I also wrote several papers and spent quite some time to look into the nano communications, how can we use the molecular technology and then to develop the computing and the communications. In the early of my career, I worked for the IBM T.J. Watson as actually in the geoscience department. Looking the department mission, of course, is looking at the computer architecture, those kind of stuff. And although I'm a wireless person, and that time I also work for the HP labs, and again I work in the computer architecture lab. That's again very strange. And although I'm a communication person, and back to the early days, and the IBM, HP are the major company. At that time, I don't think there's any Google, Facebook, those kind of company. And Microsoft and Intel are just a kind of the early stage, after the early stage of startup. And so the IBM, HP was the major company at that time. And so that would bring me across my experience from the communication also to the computer areas. And so as I mentioned, when I visited MIT, and I turned more interesting about the machine learning. Part of the reason is the machine learning and the communication. I think in terms of the theory, they have lots of the similarities. And that's why when I try to look into the artificial intelligence, for me is artificial intelligence is wide areas.
And what was your motivation for writing this book on wireless communications for AI, specifically in robotics?
Yes, and so the coming because of my background, and then I tried to look into the as I mentioned, I'm very interested about the for the 5G there will be three pillar technology, and the most I would say the area probably in the most primitive format is actually the URLC, ultra reliable and low latency communications. And so when I developed the technology for that, I'm thinking about how can we apply the technology. And so then I figure out, well, that would be very interesting because we start from the machine-to-machine communications since probably 2010. It's like 10 years ago. But however, the application of URLC, and then we gradually realize it's all related to, I call it a smart machine. The smart machine basically is a kind of, I try to have more general category name for the robots. So the first idea is autonomous vehicle, as you can imagine, and they're also including the robots. So that's why in the most recent proceeding IEEE, I have a paper talking about the wireless communication for multi-robot systems. In the factory, in a smart factory. So that will be another major application areas, and of course that will be including something. For example, we try to have the iRobot to clean the inside the house, and another looks like very simple problem, but actually very difficult is, can we develop a robot to mow the lawn for us? Because in the States, every house typically have a big lawn, and then that will be a big yard work for everyone. And so there's always a curious question: so can we develop a robot for that? So actually, I work with my students and try to develop one. And We quickly get one and one done without surprise, but then we realize it's really hard to do a good job.
Yeah.
It's easy to deliver a robot, but it's really hard to deliver a good robot to really meet the person. And so then realize it is actually a very difficult job.
Okay. And so to start with, something you look at a bit in your book is how can communication and signal processing techniques enhance artificial intelligence in robotics, which we're seeing more and more.
Yes, and so I already mentioned what you want to just have the robot, and it is not difficult. Today's and
Yeah.
in the States, you can find a 10 years old kid and assemble a robot, right? This is
Yeah.
not something unusual. And so when I ask my students and to implement the robot, I give them, okay, it's a summertime and give you guys 3 months.
Okay.
And I say, if you cannot finish in 3 months, I guess there is something seriously wrong. And so actually, it is about right after 3 months, and we can have something work. But as I mentioned, it cannot be worked in a very good way.
Mm.
Part of the reason we can imagine that because the robot actually has his eye into the world, okay, and it's called the robot split. And unfortunately, robot split is never be able to align with the true environment.
Mm.
Okay, and that is actually become very difficult. For example, if we ask the robot to walk a straight line, uh, even for that is not a trivial job because the robot have to judge its locations. So this
Yeah.
is a problem called localizations, and well, we have the one specific chapters in the book talking about this. And so how can we resolve this problem? And then actually what we are using is a lot of the wireless sensor techniques and also the signal processing techniques.
Mm.
And so that's why this is one good example. The communication and the signal processing can actually help. So you
Yeah.
can imagine, so if we have the autonomous vehicles and
Sure.
drive along the road, and how can the autonomous vehicle realize what exactly the locations? Uh, the immediate idea is we can use GPS. The answer is no, because the GPS have the arrow like 80 meters.
Yeah.
And even you have some advanced GPS technology, the arrow can be reduced into 1 meters. But 1 meter is good enough to have a lot of the collisions in real life,
Yeah. Yeah.
right? And so this is not enough. So the robot need to be using something rather than the absolutely the location, and this had to base on the relative location. So that's why the human being is good, right? The human beings
Yeah.
actually can work and we can quickly adjust and the distance. So this will be involved. That's why it's involved lots of the signal processing and techniques, and then can be useful. There will be much more. And for example, like vision, which is another typical signal processing technique, and the radar is a typical communication and signal wireless communication and signal processing techniques. And so for the robot today, we're using the LiDAR, which is using the light and millimeter wave radar. This again the radar, and we even using the sonar and using all different kinds of sensor technique. This is all related to the wireless communication and signal processing. But however, for the people in the robotics side, and they usually don't have too much about this knowledge, and for the people working in the wireless communication and signal processing, they do not realize there will be lots of the area they can apply their knowledge. So this is the purpose to have the book try to bridge the both sides.
Okay. Yeah. Sure. Um, Something else I'm interested in. So, how has the rollout of 5G impacted AI and robotics specifically?
Yeah, actually, I would explain. 5G basically have the three pillar technology. One is EMBB, that is for traditional human-to-human communication.
Okay.
But for the MMTC and also for URLC, it's primary. It's actually deal with the machine. It's rather than the human. So this actually provide very good highlight is those more advanced communication technologies actually in the future is going to serve the machine rather than serve the robot rather than just serve human beings.
Okay.
That would be probably a little bit out of the equation for most of the people, even for many people working in the areas, in the wireless area, they do not realize. Right? Why do we need so many sensors as a human beings? Actually not, but for a robot doing anything is require lots of the sensor processing, and so the real application for the 5G is actually related to the machine. So you look into those industry leaders talking about the 5G application. They are not talking about the smartphone anymore. They are talking about, for example, smart factories and autonomous vehicles, and this is all the subject, right? And so I just organized the IEEE GlobeCon last month, and so for the Qualcomm people talking about the how to apply the 5G to assist the autonomous vehicles, and the Foxconn, the vice chairman talking about how to apply into the factory environments. So this is a kind of totally different scenario. So once we introduce the 5G, because of the two new pillow technologies, actually change the application of the wireless robotics. But I have to also mention that when we're talking about wireless robotics, it's not just for 5G. It may be some like Wi-Fi or maybe new version of the Wi-Fi or something, and also the different kind of sensor network, wireless sensor network. So there will be a lot of different kind of new subjects.
Oh, okay. So it's not just 5G.
Yeah, not just 5G, but 5G is a very good point to explain about the idea because they have three very clear pillar technology. But unfortunately, I think a good percentage, probably more than 50% of people working in the 5G do not realize the new 5G, the new application for the 5G probably most related to the robot rather than human beings.
Yeah, definitely. Okay, I'm afraid we might have to end it there, but thank you very much for joining me today and talking through robotics and AI. Thank you.